Oh, are we live, guys? Are we live? Chat. Someone tell us if we're live. Mateo, can you be engaged?
I'm engaged.
What's he doing?
Bro,
Yeah.
split screening.
I'm not split screening.
Bro, split screening.
The thing wasn't working.
Alright, okay, Mateo.
It's working. Yeah, it's working. So,
Okay, wait, can we have another monitor for like chat?
give me another mod for chat.
Yeah, like you use your service for chat.
Okay, there we go.
There we go. We got the setup. Okay, nice. So, hello. As you can see, neither of us are the person on the thumbnail, but that's okay because we'll be starting the stream, and our main
The expert will be
and the expert himself is currently in an orchestra rehearsal, so he will be back very shortly. But for now, we're just going to go through some topics. So yeah, let's start. So, and these are all the paper 2 topics, exclusive to paper 2, very likely to come up. So let's start with moles. So you have to understand how to carry out calculations involving amount of substance, volume, and concentration. Is that chat?
Yeah, it's chat.
There is chat. And yeah, again, if you have any questions, feel free to put it in the chat. So we'll try to answer all of your questions. Okay, so for moles, there are essentially 3 important equations that you need to know. So for
the gas one as well. This is the gas one.
Do you mean this one?
Okay.
Yeah. So the first one is that moles is the mass of the substance in grams over the molar mass, which is in grams per mole. And in order to calculate the molar mass, you need to use your periodic table and add up the relative atomic masses of all the elements. Am I right?
Yeah.
Yeah. Okay. Good. And then this guy's my helper. He's also an expert, and he's gonna be fact checking me for the opening minutes of the stream.
Exam board. At Excel, right?
Yeah. Sure, they're not supposed to know it's at Excel. The whole point is that we're pretending it's accurate.
It's both.
Yeah, it's both. Whatever exam board, we've got you. Okay, the second one is that if you have a gas, and I'm assuming this is in room temperature, but that doesn't really matter. The moles, the amount of a substance is the volume over the molar volume, and the molar volume is 24 dm cubed per mole. So actually, let's write that in. 24 dm cubed per mole.
The main way they'll catch you out with these questions is to make sure to read if it's in cm cubed or dm cubed, and make sure when you're converting it's 10,000, not like up 10.
What?
Because like
10,000.
1,000.
1,000. Or it's 1,000.
1,000.
So 1 dm cubed is actually, wait, can we? How can we get this? Oh no. It's fine. Right. Keko, we support all of our guests. Okay.
So just make sure to read the units before you answer the question.
Yes, exactly. By the way, like I'm pretty sure my face is here, so we don't. Okay. Mm-hmm. And the third equation, I thought moles of paper 1 for Excel. No, they are not. I kind of want the guy in the thumbnail. He will be coming.
He's late. He'll be there. He'll be there in a bit.
Yeah. And moles in a solution is the volume times the concentration. Actually, a really good way to learn these equations easily is to know the units. And so you can derive the equations basically off of the units. So if you know that concentration is moles per dm cubed, then you know it's moles over volume. And again, as my guest over here says, wait, do you mind being name dropped?
Okay.
Yeah, so as Matteo here is saying, they'll catch you out with like 100 cm cubed. Don't divide by 100, divide by 0.1, because 100 centimeter cubed is 0.1 decimeter cubed. Can you do condensation polymerization? Yes,
Yeah.
that is one of our topics.
It'll be covered by the guy who's really good at organic. Who's in
Who's fourth in the UK. He is the fourth best chemist in the UK. It says on the spec P1. Well,
you're gonna need it. I've done a bunch of papers.
It
always comes up.
It did not come up in P1 in paper 1, which means it's doubly likely to come up in paper 2. In fact, I think it's guaranteed to come up.
It's 100% guaranteed to come up.
So it's very important that you nail this down. So how do you go about answering mole problems? So it's 4 steps. First, you have to write out the balanced equation, and then you want to convert the information in the question into moles. So as you see here, the question is, what volume of oxygen is needed to completely combust 0.8 grams of methane? So you first write out the equation, and then you convert everything in all the masses or volumes or whatever into moles. And then you use the molar ratio, which is given to you by the chemical equation. So as we can see here, the CH4 to O2 ratio, well, it's 1 to 2. Every 2 moles of oxygen react with 1 mole of methane. So the molar ratio is 1 to 2. And so you need 0.1 moles of oxygen to react with 1 mole of methane. And when you see these 1 and 2, they're the molar ratios. They're not the mass ratios. They're not the volume ratio. They're the molar ratio. Yo. What's up, first time gang? Yeah. If this is your first time here, make sure to subscribe. We've got lots of good content on the way. Yeah. I mean, I think Matteo is quite new to this streaming stuff. So, yeah. Okay. I'll let Matteo talk about bonding.
Bonding?
Yeah.
Do you not want to do one of the things they're like actually asking for?
Do
you not want to do what some of the chat's asking for? Like, is it equilibrium, water?
If you stay tuned in, then we will eventually get to dynamic equilibrium. I'll literally scroll down. Dynamic equilibrium is right here.
We'll do the bonding then.
Yeah, we'll do the bonding.
For the bonding questions, the main thing is just write a lot, because they're usually looking for like a specific phrase. So if you just write an essay for the question, just write like a bunch of keywords, scattergun it. But a lot of the time it will ask for like regular structures, lattices. Just like write the full name if in doubt. There's the expert.
Hello guys! I'm gonna be taking power from now on. Right. So, where were we?
Just like go through the stuff. Also, I forgot to put a paper, so you might have to like insert paper.
Yeah, it's fine.
Wait, can I watch the stream on your surface?
Sure. Wait, I'll be right back.
Okay, you can watch.
Swear.
Right.
Wait,
where's YouTube?
Wait, I think we were muted for the first.
How do you use this?
No, they heard us, bro.
No.
Oh, right.
Go, just go.
Okay.
Just go.
Right.
Your screen.
Metallic bonding. So, what is metallic bonding? Metallic bonding is the electrostatic force between metal cations and a sea of delocalized electrons. Okay, I've got that question at least 10 times in the past papers, so remember that. For these, you don't really need to know them in that much detail. Just know the bonding, and then if they ask you to explain why that happens, just use the model of bonding in like the diagram.
Just say electrostatic attraction because it's always the right thing to say.
Okay. Should we do past paper? Have you done all of it?
No.
Oh my days.
You have to get the first.
Okay, a bunch of people want equilibrium, a bunch of people want water. No.
Right, okay. Let's do equilibrium.
Yeah, because that's actually relatively annoying.
What? Right. So, equilibrium. So, there are like 3 types of questions I can come up with equilibrium. The first one is to define equilibrium. So for those, you just have to learn the marking points. Okay. So those are the marking points. 1, both reactions happen. I'm not top 5 in chemistry, little bro. Calm down, mate. Happen at same time. At same rates, number 2. To not write in the top. Okay, thank you, Brack. At same rates. Number 3.
Yeah, like this.
Conc of reactants and products constant. Oh my days. So if they ask you to define equilibrium, just write those 3 points.
Also write it's in a closed system.
Yeah. And if they ask you to describe like equilibrium, you need to write all the points. And then macroscopic properties constant. So macroscopic properties is just like pressure or temperature.
Yeah, like look, this is literally on the model scheme. It's literally the first 2 points.
Wait, is that define?
Yeah, it's defined.
If it's described, you need to write more. If it's more marks. Devin Kumar. No way. Hello, Devin. Oscar O'Carroll. So I've heard of that name before. Okay. Right. So those are the things you need to learn. Let's make it red. Okay. Right. Okay. So we did that.
Then it's the things that change the
Catalyst does not affect.
Yeah, it's the thing where it's like
okay.
they're both. It'll be like, why does a catalyst not affect the position of the equilibrium?
Okay, so the next type of question they'll ask you is they'll ask you about how a change in temperature or pressure or like concentration of reactant shifts the position of the equilibrium. So here you need to use the Le Chatelier's principle. It sounds complicated, but it's basically just the equilibrium shifts in the direction to counteract the change of the reaction.
Yeah.
Is that good?
Yeah, that's good.
So let's say if we have like H2 plus O2 equals H2O. Oh, shit. Okay. Okay, and this reaction is very exothermic. Okay. And that's why you see like
do the reverse because you can actually lose marks if you don't do the reverse.
Right, fine. And that's why this like explodes because it's very exothermic. So I'll write
Changing it.
like exothermic, or delta H is a minus something. So they'll give you like this equation in the question. And here are some things they might ask you. So if they ask you increase in pressure,
It's probably the most difficult one.
then so increase in pressure, what would that cause? That will cause the thing to go right?
Yes.
Okay. Go right.
For pressure, so essentially for any of these is going to be it. So what happens? The reaction is going to change in a way which reverses what's just happened. So because the pressure increases, we want to decrease the pressure. The way to do that is by making more of the product, which is going to have less moles. So because on the left side, we have 2 moles of hydrogen gas and 1 mole of oxygen gas, there's 3 moles overall. On the other side, we have 2 of like hydrogen peroxide. So it's 3 to 2. So because the pressure increases, we want to decrease the pressure. We want the less moles. So more hydrogen peroxide is going to be produced.
Yeah. Thank you. Okay. Basically what you said. Because you want, if you increase in pressure, you want to decrease the pressure, and so the reaction will go to the side with fewer moles, as you said.
Another thing they like to do to catch people out is moles of stuff does not count if it's not in gas form. If it's a liquid or solid, it does not count. So I don't know, reaction for this. It doesn't matter. But just if it's a solid, then don't include it in the counting.
Yeah, so you only want to count the moles of gas, not the moles of like anything else, because the moles of anything else won't change the pressure. It's only the gas.
Someone's confused. What are you confused about? We'll just continue. You just type what you're confused about.
What are you confused about?
Yeah, saying I'm actually confused doesn't help.
Wait, type as in like type in the wall?
No, not you.
What?
The guy in the chat.
Hey, my bad. And okay, and the second thing they'll ask you is increase in temperature. So
it's same thing but easier because
you increase the temperature, the equilibrium will want to decrease the temperature. So the equilibrium is going to go in the endothermic direction, because the endothermic direction absorbs heat from the surroundings, and that decreases the temperature. And because the forward reaction is exothermic, then the backward reaction will be endothermic, because the backward reaction is just the reverse of the forward reaction. So increase in T will go left. All right.
Pressure and
that's it.
Yeah, that's it.
Okay.
That's dynamic equilibrium.
Yes, great. What else should we do? Should we do organic chemistry?
Yeah, because a lot of people want organic.
Right. Okay. So organic chemistry is also another paper 2 topic.
We have to go through all of it because a lot is easy.
Right. Where do we start? Let's start with alcohols then.
Or we just go through every single type of thing.
Type of thing?
Like organic molecule, we just go alkane, alkene.
Alright, okay. Let's just go through all the functional groups then. Right. If they ask you to define a functional group, then this is the definition.
There's usually like 7 marking points though, so just any of these will like do.
That's homologous.
Homologous series. Functional group.
Functional group is a group of...
Oh yes, homologous series.
Group of atoms. that give the molecule its chemical properties. Is that right? Making such no.
Say that.
Alright, I think that's the definition, at least.
Yeah.
Okay, yeah. And for GCSE, you need to know a couple of them. So the simplest one is just alkane, right?
Yeah.
It's alkane functional group.
Well, it's just the base one when there's no functional group.
Alkane basically is just no functional group, so it's only a carbon and a hydrogen.
Another question they love to ask is like unsaturated hydrocarbon. So for so they'll usually give you an alkane and they'll say maybe it'll be like one question or two questions. It'll be one of them will be describe why it is unsaturated. And one of it will be why is it hydrocarbon. For the hydrocarbon, there's 2 marking points. It's you get one point for saying hydrogen and carbon, and the other point is literally just for saying only. So it's only composed of hydrogen and carbon. So that's why it's a hydrocarbon, and it's unsaturated because
unsaturated.
Yeah.
So C multiple bonds.
Yeah. They're just throw the chat roast. It's alright. It's alright. They're just doing stuff.
Right. So those are the functions. Those are the definitions you need to know. Right. Let's start with the functional group things. So alkane is literally just nothing. So there's like
General formula.
Okay, general formula.
CnH2n plus 2.
Yeah. So literally it's just nothing. It's just carbons and hydrogens. Right. Alkene has one or more carbon-carbon double bonds. So you would draw like this.
It has one double bond. So.
And the general formula CnH2n. Because if you think about it, you're just like removing 2 of the hydrogens from 2 neighboring carbons and adding a bond between them. That's how you make an alkene. So that's why the general formula has 2 fewer hydrogens.
Oh, and if you because a lot of them at the time will ask you to draw these, just to check it's right, just check that each carbon only has 4 bonds and each hydrogen only has 1 bond.
Yeah, it's very important. Okay, alkane, and then alcohol.
We'll just do a bunch of reactions.
Yeah. Alcohol has...
It's just an alkane, but with an O before an H.
Yeah. So it's a compound where C is attached to an O that's attached to an H.
Why would you draw it there? Just draw it at the end, no?
That's fine. Doesn't matter.
Okay, wherever.
Alcohol. General formula, CnH2n plus 2O. Yeah. I don't think you need to know that.
You don't need to know. You'd only need to know for alkane and alkene, and if not, you can just figure it out. It's just an alkane with an O.
Yeah. I saw one for carboxylic acid. General formula for carboxylic acid.
Yeah. That will come up, but you can figure it out quite easily.
Alcohol. Can we do metal uses and alloy uses?
If you stick around, we'll go through most of the stuff.
Right. Yeah, we'll do that next then.
Yeah.
Carboxylic acid. Alright. Carboxylic acid is like a bigger functional group.
Just circle it afterwards.
Yeah.
And red.
Red. This is this one. So you have a C that has a double bond to an O, that has a single bond to an O, that also has a single bond to an H. And then ester. Oh no.
For carboxylic acids, if they just react with like metals and like they react like a normal acid, so it'll just one of the hydrogens will get removed and it will just be like ethanoate or methanoate. Is there? Yeah, there's methanoate.
Yeah.
So it'll be like lithium methanoate.
So yeah.
Do
Right.
polypeptides and condensation bonds with boxes.
With boxes. Okay.
It's just the. We'll get to that with like the. Do we need to know amide groups? Yeah, we can go over it then.
Yeah.
But we need to know like diesters or what.
Right. So ester, you need to know how to name an ester. So basically, you take. So you see how there's an O in the like between two chains of carbons. So you take this one. And you count how many? 1, 2, that's 2. And this one has 1. Okay. So then the one with 2 will be eth. And the one with 1 will be meth.
Don't presume that like the one on the left is going to be the starting thing for the ester.
Yeah.
So that does not mean that's ethyl methanoate. It's not. Because what you've also got to look out for is which the double bond O is attached to, because that's where the carboxylic acid comes from.
Yeah.
The carboxylic acid bit is the one on the right. The
Alcohol.
And the alcohol is the one on the start.
Yeah. So just look at the two like groups of carbons. You first take the one without the double bond O, so it will be the one on the right. So and you add YL, so it becomes methyl. And then you look at the one on the left with the double bond O, and you add O8, so that'll be ethanoate. And it's called methanoate because it comes from ethanoic acid and methanol.
Yep.
Okay.
So we're probably just going to go over a bunch of reactions now for the organic, because that's what they tend to ask about the most with organic.
What do you?
Just a bunch of reactions for it.
Reactions. Okay.
Let me just put up like a thing of all the reactions.
Yeah. All right. So let's see. Hydration of alkene. So with an alkene, if you have ethene and you add water, it becomes ethanol. You need to know the conditions of this reaction for Edexcel at GCSE, and that is
Phosphoric acid. 300 degrees Celsius.
What is this thing?
It's Grammy, bro.
Okay.
Not sponsored.
Yeah.
So common phosphoric acid,
phosphoric
300 degrees
acid.
Celsius, and 60 to 70 AMT. Just write one of them, like 60 or 70. Okay. Then you don't need dehydration. Do you need dehydration? I've got literally everything. All in there.
Yeah. Okay.
Why is-
Dehydration. Yeah. Dehydration.
It's just alumina plus heat. You don't need a specific heat. Just heat.
Alumina plus heat.
For
Okay.
alkanes, you've got cracking. This is the other one where you actually need to know the reagents.
Cracking.
It's just alumina or aluminium oxide and 600 degrees Celsius.
Alumina and silica. Right.
Alumina and silica.
Yeah.
Okay, alumina and silica. You get them. Yeah.
So, alumina and silica.
Yep.
Or You can write it in like molecular formula. And 600, 700 degrees. And cracking makes alkanes, smaller alkanes and alkenes. Okay.
They're just spouting bollocks.
Right, cracking, hydration, alcohol. You need to know oxidation of alcohol. That's gonna make carboxylic acid. And if we, okay, let's just change this example so that it is at the end.
What did I say?
Yeah. So if we have propanol, because that's 3 carbons, it's going to make propanoic acid. And it will look like this. And
you need a reagent for this.
Reagent.
So the conditions to do this is you need to be in a reflux environment. That just means it's closed, right?
Yeah.
Yeah, so you need to be a reflux environment, which is just a closed environment.
Reflux.
And you need acidified potassium dichromate.
Yeah.
Sometimes
dilute sulfuric acid.
No, because if it's acidic, so you can just write acidified potassium dichromate. However, sometimes they already give acidified, like they give potassium dichromate, and they'll ask, what's the other reagent? And you have to add an acid. Just do sulfuric because hydrochloric creates bad gas.
So acidified sulfuric.
Yes.
Acid. And potassium dichromate, you can also write. Okay, yeah. Potassium dichromate. They might ask you about the color change. So it goes from orange to green.
And if they say what species causes this, it's the chromium ions.
It's just dichromate.
It's dichromate,
yeah. What example is this? This is Pearson
NXL, but it's also used for AQA.
Why is cracking useful? Oh my
god. Oh no,
goodness.
This actually it usually is a very long marker. It'll usually be 5 marks. So why is cracking useful? So the 2 things you've got to be, so it produces shorter alkanes.
Yeah.
So shorter alkanes are better because the shorter the alkane, the more flammable it is. So it's going to be a better fuel. They often like you talking about how shorter alkanes are more in demand than longer ones as well. So just like that.
Makes shorter. Makes.
I'll just let them keep it on the notes. They're more flammable. They're in high demand. Okay. And they make alkenes, which can be used as a base. They're base monomers for polymers like plastics.
Yeah. So alkenes make plastics. Alkanes
make better fuel.
Make fuel.
Yeah.
Yeah. Okay. Well, I think that's everything.
For organic?
No, for useful.
Yeah, for useful.
Right. Carboxylic acid. You also need to know how to make an ester. So, oh my days, it's spazzing out. What is going on, bro? What is this?
Mate, stop taking carrot. Stop Team Schattenbrack. It's annoying.
Okay. One is spazzing out again. Right. So, next one. Ester. So, carboxylic acid and alcohol, they combine together to make an ester. And for esterification, you need concentrated.
No, it's just dilute.
Oh yeah, concentrated. Yeah.
Okay. Dilute. Concentrated sulfuric acid.
Dilute will make it go the other way.
Oh yeah, sorry. That's right.
Sulfuric acid.
And this is a reversible reaction.
Yeah.
So make sure to do like the double arrowheads if you're doing a reaction on this.
Alright. Okay. Dilute sulfuric acid.
What?
Oh yeah. Wait, I think you're talking about oxidation. This is chippy chips. What's chippy chips, bro? Right, ester. I think that's all you need to know.
You need to know it's reversible. So if you add water back, it'll go back to a carboxylic acid and an alcohol, and it has a fruity smell.
Oh yeah, okay, fruity smell. So they'll say like,
Really dodgy.
what? Why? How do you know that an ester is formed after the reaction? You can write fruity smell or oily drops. Okay.
Do we need to do combustion? Because I think that's pretty self-explanatory.
Yeah.
Just
yeah.
You know combustion, guys. It's fine. I'm not gonna fail.
Can we have a championship style lesson?
Right. Actually, stop.
Yeah.
What else is there?
The one is not working, bro.
For tests for unsaturated stuff, that came up in paper 1, so I don't think we particularly need to do that.
Okay,
What's the one that's
I need to restart one.
You know?
Wait, I'll be back in a bit. Hello. We're back. One is working again.
I also didn't say IRL. Can we not have hate? I know you live, Fred. Stop it, Brad.
John Lang.
What?
Wait, who? Jupalufa?
No.
Okay, right.
Well,
It's time for
that.
John Langdon.
John Langdon,
Please
shut
stop
up.
Alright.
Do the feature on Jupalufa. Fair
Okay,
enough. Fair enough, Fred.
let's just move away from organic chemistry. Let's go to what did Brad say? Does anyone want any topic
like specifically
that I want to cover? That you want to cover? Should we just do a past paper?
We can. In the chat, right? Do you want to do a past paper or do you want to just do something else, like topic wise? Stand up paper. What?
We're just waiting for like topic suggestions and stuff.
Well, no, it's awesome. We just want to do a past paper.
Wait.
You won't break.
But you be right back or what?
Just go back, bro.
Yeah.
The worst thing you can do is turn off the stream.
We've got pretty good
Oh.
view.
Okay, wait, where's my...
Oh, you're just muted.
No.
We're just,
Oh,
we're just
no, not
talking.
muted.
You're not even muted.
Yeah, no, it's fine. We can just talk.
So
chat.
I can't
We can
swear.
talk with chat. You can swear if you want. I don't care.
can't.
It's Barack's channel.
That's true.
It's Barack's channel. I don't
That's
know.
true.
It's like
Mateo, can we talk about the time? That time, the conversation we had
Very
last
bad.
evening. Should we share it with the world?
what's all this hate I'm getting from Freddie, bro? We want bread paradoxes.
What were you guys looking for?
He's downloading a paper. I thought he was downloading a paper.
I am downloading paper.
Well, just search up a paper, bro. Townsend said keep it go up. Thank you, Townsend.
Thank you. So,
Bro, we want bread paradoxes.
Right.
Can Dr. Follows enter chat 100%?
What? Gosh. On stream. What are you on?
On the street. Oh, see, there we go.
Right. Shall I do a past paper?
There's a poll. There we go.
Guys, there's a poll. Vote if I should do a past paper or not. Because I'm going bored from covering all this, bro.
Oh, I can choose. I can choose.
Go on.
I want to do a past paper.
Flame
No,
spectroscopy.
I can't because I have not signed it.
Let's. Can you do triple I? Can you do flame spectroscopy? Yeah.
What? No.
Flame spectroscopy.
Okay, thank you. This is
Oh,
crazy.
thank you.
Go get it yourself.
Flame.
Chat.
Basically,
Who wants a
like-
cookie, chat?
Oh my days. So flame. If you just have a thing, and an ion, if you have and you burn it, it will produce an emission spectrum. And it'll look like a rainbow, and it has stripes on it.
People
And
aren't
you-
gonna watch. People aren't gonna watch. No, everybody just see.
That's triple. I think it's triple high.
Is it?
And you can, and the each metal ion will have its unique stripes.
It's not racist. We are not maintaining the viewership. Right? We're dropping.
No,
They're dropping like flies.
So basically, it will be line spectrum. Okay, it's called a line spectrum.
Hi, can you help with moles, please?
Yeah, we can do.
There's an entire mole section. If you just go back, watch the first bit of the stream.
Alright.
We do the whole thing.
Okay, this is flame spectroscopy. Burn line spectrum measure wavelength. That's
Okay,
it.
cool. Alright.
Wait,
I don't know what happened to the poll. What happened with the poll?
yes, 80%.
Okay, we'll just do a paper.
Okay, let's do past paper. I'm just gonna pull the past paper.
That's probably more useful to fight. Extreme molten versus thing. Okay. You can while she's downstairs the paper, I'll explain that.
Yeah.
So there's molten versus aqueous. So obviously so the reason firstly that there needs to be molten or aqueous is because the electrolyte, that's the thing that the cathode and the anode are in, need to conduct electricity. And current needs to pass it through. Current needs to pass through the electrolyte. Now in aqueous, obviously the issue comes because there's water. Now this causes maybe not the ions in the solution to form on the anode or the cathode. So so halogen, so on the cathode, no, on the anode, if it's one of the ions is a halogen, then that halogen will form on the thing. If it's something like a sulfate or a nitrate, rather than that forming, oxygen will form because the water will be undergo electrolysis. On the cathode, anything below reactivity of hydrogen will not form, and hydrogen will form instead.
Okay,
Is that
great.
right?
Yep. So, yeah.
In molten, you don't have this issue. And for both, so a lot of the time it will be like, why does the ionic compound have to be molten for electrolysis to take place? It's simply because the ions need to be mobile. In a solid, they can't move; they're fixed in bonds. In a liquid, they can move over each other, they're mobile, so they can carry a current. There you go. Just masking.
Yeah. It's June. Right. Okay. So we got paper. Let's just go through the paper real quick. Right. Use the periodic table to help you answer this
Just
question.
show them the paper we're doing, so they can do it with us.
Yeah. So we're doing Pearson Edexcel International GCSE June 2023 paper 2C.
And if you need to find it, just type CH1-GC.
So I can just send this in the
I
chat.
actually think I just did this one.
What?
I actually think I just did this one. So it's good.
Okay, I sent the link in the chat.
You can see if I failed this paper because I just did this.
Alright. Okay, let's start. Name the element with atomic number 14. So let's go back to the periodic table. Oh my days. One is so bad. Right, I'll just have to look at this sideways.
No.
Atomic number 14. So,
Oh, yeah, I just marked
atomic number is the bottom number. So, we just need to search for one that has the 14 as the bottom number. And we found it. Silicon. So, let's go back. Silicon.
Good.
Name the element in group 2 and period 3. So, group number is the number along the top. So, that's the group number.
I'm going to. Don't cry, you'll be fine, bro.
And
You'll be fine, you'll pass.
period is just the rows. So, if you look at it sideways, wait, that's wrong.
This
So-
is higher, so but obviously it includes foundation.
So, what do we need? Group 2. So, group number is the columns. Group 2, we found it. Period 3. And you just find the box. That's in
For
group 2.
periods, make sure that you're including hydrogen and helium as period 1.
Yeah, so for this periodic table,
Because the hydrogen's there. It might not look like there's a period 1, but there is.
yeah, so period 1 is there. So, magnesium. Name an element that is liquid at room temperature. You can't really use the periodic table. You just have to know. Bromine or mercury. Just have to memorize that. Give the electronic configuration of an atom of phosphorus. So let's go back. Go to phosphorus. So phosphorus is in period 3. So that means it's going to have 3 shells of electrons.
We'll just remember, like, first shell can have 2, second shell can have 8, third shell can have 8.
Yeah.
You won't need to know anything more.
So, because the first, it's got 3 shells, so the first 2 shells will be 4. So the first 2 shells is going to be 2 and 8. And then if we go back to phosphorus, you'll see it's in group 5. And that tells us it's got 5 valence electrons in its outer shell. So we'll put 5. Give the formula of sodium sulfide. So sodium is in group 1. That means it's going to be Na+. And sulfur is in group 6. So that means it needs to gain 2 electrons to make a full shell.
So it's ionic bonding, so
So
the charges just need to cancel out.
Yeah. So if we got Na2 plus Na plus and S2 minus, you need 2 pluses to cancel out 1 2 minus. So it's going to be Na2S. Explain why neon is unreactive. So if we go back, neon is here. So it's in group 0. So it'll be a noble gas. And one of the properties of noble gases is that it has a full outer shell of electrons. So it's hard to lose or gain.
That's the key phrase. That's the
Yeah.
key phrase there. Learn it.
Yeah, learn it, please. Right, question 2. Alright.
Why is someone typing Russian?
Я думаю,
John-
что русский язык плохой.
Oh!
Я согласен.
John Landon actually, like, this is chemistry, bro.
Which of these gases has the lowest percentage by volume in the atmosphere?
How do you? Wait, I'll just do.
So, right. This is just memorization. Argon has 1%, carbon dioxide
Oh,
is 0.04%,
0.04.
nitrogen 70%, and oxygen is around 20%. Right.
The Jupalupa imposter is John Langdon. Find him.
is around. Okay. Oh, oxygen is around 16%. My bad. So, which one has the lowest percentage? Obviously, this one because it's 0.04. Copper carbonate is heated. Copper 2 oxide and carbon dioxide form. What's the name of this type of reaction?
So it's one big thing.
One thing going to two things
through heat. So it's
decomposition.
And it's specifically thermal decomposition if it asks. Yeah.
Copper carbonate. What's the color change? So copper carbonate is green. And copper 2 oxide is black.
So copper usually forms blue stuff, but copper carbonate is weird, so you just need to know that.
So it's green to black. Yeah. Give the chemical equation for this reaction. So let's write out the symbols. Which one? So, okay, fine, yeah. Copper carbonate is CuCO3. Copper 2 oxide is CO, and carbon monoxide is CO2. Right. The student uses this apparatus to find the percentage of oxygen in a sample of air. The student leaves the apparatus until there is no further change in the volume of gas in the syringe. Calculate the volume of oxygen in the sample of air. Give your answer to two significant figures. So, what's it asking? It's asking basically the volume of oxygen over the total volume of air. So if we go back to the diagram, volume of gas in flask and connecting tube in CM3. Yep. So that's this bit, isn't it?
Yep.
And that's going to be constant. That's 280. Volume of gas syringe at start is 100. And at end is 27. So initially, when there's air, when there's air in the thing, it's got 100 in the gas syringe and 280 in the conical flask.
17.
So the volume of air is going to be 100 plus 280. And the volume of oxygen. So what is the reaction that's going on? Wet iron fillings. So you should know iron rusts and it consumes oxygen. So the only gas that's going to be consumed is oxygen. And that's recorded by the difference in the volume. So the volume of oxygen is 100 minus 27, which is 33. What?
For maths
73.
Answers, well, for maths answers, you just need they don't particularly care unless it's specifically asked. Just do as many as you probably can think is reasonable. But unless it asks for decimal places or sig figs, definitely read the question carefully and read it to the end, because it's a very easy and stupid way to lose marks if you just don't read it and then you get the right answer but you don't put it in the right number of sig figs.
380.
380.
My bad.
Some chemi whiz you turned out to be.
19.2%. Great.
What's
Okay, should we go from the back?
Back? Why?
Should we go? Okay.
Why would?
Are we going to go through the entire paper?
Yeah. Probably.
Right. Explain why an increasing amount of carbon dioxide in the atmosphere is likely to cause a problem for the environment. Problem for environment. So, carbon dioxide. What's the effect of carbon dioxide on the environment? So, carbon dioxide is going to cause
greenhouse effect.
Greenhouse effect.
Just for any geography hour question, just always write greenhouse effect and global warming because they want one or the other. Or is the homeless man salary?
Come on, why can't you just do it on your surface?
Huh? Because my surface pen doesn't work and I kind of want to do the graph questions as well.
Alright, okay, fine. Complete. So, this question is about alcohols. Ethanol can be made from hydration of ethene or fermentation of glucose. This is a reaction for hydration. Complete the equation for fermentation. So fermentation makes ethanol, that's given, and carbon dioxide. So we're going to make ethanol and CO2. And we just need to balance that.
No, we can't remove John. We need the viewers.
So, let's look at how to balance this. On the right side, the only thing that has hydrogen is ethanol, and that's got 6 hydrogens. Okay, this one has 12. So we're gonna need 2 of ethanols,
and 2 carbon.
That means that we've got 2 times 2 is 4 carbons from ethanol, and we've got 6 carbons. So we need 2 carbon dioxides to make up for the 2 carbons remaining. All right, hydration catalyst.
Thank you. Oh yeah, so you could stay somewhere nice.
Hydration catalyst is conc H3PO4 phosphoric acid. Fermentation temperature is 30 degrees to 37. I think they accept a range.
Oh wait, for like the
That's 30. Okay, never mind. Pressure in atmospheres 60 to 70. We already went through that. Okay.
Oh, they love doing the advantages between and disadvantages between fermentation and hydration. So explain one advantage, one disadvantage using fermentation, and hydration to use ethanol. So obviously fermentation. So I'll just try and go through as many as possible because there's usually also be like 5 marker. Firstly, it's a lot slower.
Okay.
Well, so firstly, it's a lot slower.
Okay.
Secondly, it's a
slower.
batch process, so it's a disadvantage. So you can't like add and take away stuff because that's just messes up the reaction.
Yeah.
And that's about it. Fermentation. Oh, and it's less pure. It's less pure.
So it can't use for industry.
Yeah, so it's less pure. So it can be an advantage if it's like. Yeah, whatever.
Right.
The review liver.
Where's the original?
He's dead.
Yeah,
he had a
he's
heart
dead.
attack.
Advantage of fermentation.
I mean, it's no real surprise there.
Say, use non-toxic.
Yeah.
Materials.
So, for example, phosphoric.
Because
phosphoric acid is corrosive.
Is toxic.
It's corrosive. Keely.
Corrosive.
Yeah, they like it if you use corrosive. Yeah. It's faster. So no, it's not. So it's not toxic.
It's
less expensive because less extreme conditions.
less extreme.
So as in the high temperature, high pressure. And there usually tends to be a bunch of like geography things it's non-renewable. So fermentation, it is renewable because obviously you just grow it from sugarcane for the sugar.
Renewable.
But also a disadvantage is it's a really geography one. The use is the last resort if you it's like a long question and you just need to write more. It's like they take up fields where agriculture could be grown.
Okay. Take up fields.
You will not need to do more than 7 marks. I think that's about it that we need there.
Okay. Right. Explain why fermentation needs to occur in the absence of air.
Just the yeast needs to anaerobically respire.
Yeah. So yeast yeast needs to be anaerobic.
Yep.
Because as you know, if you have oxygen, the respiration's going to make water
and carbon dioxide is your biology. And then just write some random second point.
Yeah.
But here it says so ethanol can be formed. So just write a lot and hope you get the second mark because it's in God's hands. If the other explanation is so ethanol would oxidize and it would produce ethanoic acid like we went over before with the. Why are you confused? Okay.
I don't know. I'm a bit lost.
Can I watch even if I'm doing IGCSE? Yes.
Yes.
We're literally doing IGCSE paper.
It's literally an IGCSE
It's the
paper.
same.
Do not question anything.
This is paper 2. Yeah. But
It's all
the
useful stuff.
Yeah, the majority of the content is the same.
There we go. For the guy who asked how to do the empirical formula stuff, this is it.
So what are we gonna do?
So just treat the percentages as masses.
Yeah. So imagine if we have 100 grams of propanol.
Yeah.
Then 60% of 100
So
grams.
just write the equation on the side, like the thing, like the CN, like the
This
N,
one?
the N, no, like the M, like just like the triangle thing.
I know what you're talking about.
And
Yeah.
mass. So that's
Yeah.
one.
Okay. So this is the equation you need to know. N times mr equals
20%.
m. Oh my days. Right. 60 grams. 13 grams. 26.7 grams.
Yep.
So what do we want? We want to get the moles because we want to get the ratio of the atoms.
Yeah.
So moles, how do you get moles? Is m over mr.
Yeah. So you can just,
So
for any of these formulas, if you just write them in triangles, cover the one which you want, and then it will just be like, so that, like, I don't know, you can't see my thumb. But if you cover the mass, it'll be the N times the MR.
Okay.
For this, we want the moles, so it's M over MR.
right. So what are we gonna do? M over mr. 60
not
over
writing
12 is 5 moles. 13.3 divided by 1 is 13.3 moles. And 26.7 divided by 16 is hold on, 1.67 moles. So for these ones, if you have like not good numbers like I have,
Yeah,
just divide by the smallest number.
because it may look a bit scary, like you may think you're doing, but just press on, just divide and hope for the best. And it's not obviously going to be exactly 3, but just look in your calculator, it'll be like 2.99 something here. So it's essentially 3.
Yeah, so that's basically 3.
That's-
13.3 divided by 1.67. So
As mean
7.96.
as mean as the exam boards are, for these questions, if you divide by the smallest one, you'll always get like a nice number, like basically a whole number.
So now you just round to the nearest
whole number.
Yeah, you get 3/1. So that's consistent with C3H8O.
So this,
Propanol.
so this is what we were talking about before. So with your naming, so obviously you've got for naming, you've got monkeys eat proper butter. That's a way to remember it.
Yep.
So 1, 2, 3, 4,
Me,
and then it's just like
me,
pent hex.
prop beat. So propanol is gonna have 3, isn't it?
Propanol's gonna have 3.
So we're gonna draw the 3 carbons first, and they're gonna be bonded together. Now we're gonna draw an O that's attached to an H because that's the functional group.
Yep.
And then just fill the rest with H's.
And just so a way you can check this if you're a bit scared is firstly make sure every carbon is bonded to four things, so there'll be 4 lines, and just like maybe write out the molecular formula and just count you've got the right number of hydrogens, right number of carbons, right number of oxygens. There we go.
Right. Student does a titration. Okay. Give the name the most suitable piece of apparatus to measure out 25.0.
Because there's a 0.0, it means it needs to be accurate, so you use a pipette.
Yeah.
Usually it's a pipette or a burette or like.
Is that the medium used to like make what vehicle?
Give the color of
It's used to
methyl
make
orange
like
and calcium
aircraft because it's light.
Yeah, aircraft, exactly.
and dilute sulfuric acid. Color. So methyl orange. What does methyl orange do? Methyl orange is yellow in acid.
Monkeys eat peanut butter. Monkeys eat proper butter is better because it's propane. So you've got. Yeah. Yes.
What time does it mean? What time does it mean? What time does it end? What time does it end?
Right. So potassium hydroxide is going to be a base, isn't it? So it'll be red.
It ain't common.
And sulfuric acid is an acid, so it'll be yellow. That's that. Why does the student place the conical flask
It's just so you can see it
conical
better.
flask on a white tile?
These
So
stupid questions.
see color change more clearly.
We're just gonna skip by because this is pretty obvious.
Swirled mixed contents.
Mixed contents, yeah.
It's red in acid. It's red in acid.
Red in acid. What?
It's red in acid.
Yeah. What?
It's red.
Oh wait.
Yeah, it's red. It's
I
just
got
like
the wrong
every.
round.
Bro,
Oh wait.
I wasn't focusing, but like.
Oh.
Okay, Kong, shut the hell up.
Wait, what? Are you sure?
Yeah,
Yes.
yes.
I'm a bit cooked, bro.
It's
red in acid.
yeah. This man is rubbish.
Never mind.
But yeah, for most of these indicators, if it's red, it's probably acid.
Okay. No.
It is chat cooking us. Chat is indeed cooking us. Oh dear.
Oh no.
You might as well just stop watching because we clearly don't know what we're doing.
Yeah. Right. What is meant by concordant results?
I don't know why.
Concordant results are results within
Barack, I want my money after this.
0.20 cm cubed of each other. Okay.
Who's this A level?
Huh? A level is better.
Yeah. Who is this man? Why are you watching a GCSE
A
stream?
level.
Do you not have A levels, bro?
Right. Let's do the it's calculations again. Right. Find the concentration of potassium hydroxide.
So obviously, so
15 of sulfuric acid of that. So firstly, we need to calculate moles of sulfuric acid. Okay.
also make sure to read like the entire question and the equation, Keely, because that's probably the most helpful thing.
15. So 15 centimeters cubed is 15. You need to divide by 1,000 to get decimeters cubed. And then we times the decimeters cubed by 0.180 moles per decimeter cubed.
But who is this? Can we keep that thing? What the fuck's going on in the chat? The chat is doing weird things.
0.0027 moles.
Oh, for God's sake, fuck off.
0.0027 moles. Okay. Now, we want the concentration of potassium hydroxide, so we need the moles first. NaOH. So if we look at this equation, 2 NaOHs make 1 H2SO4. So the ratio is 2 to 1. So if we have 1 H2SO4, we need 2 times that amount to neutralize it. So it's going to be 2 times 0.0027. And that's going to be 0.0054 moles. And now, finally, we have the volume here. So the concentration of NaOH is just 0.0054 divided by 25 divided by 1,000, because you have to divide by 1,000 to get
The DM cubed. So that's the thing where you might lose marks. Wait, do you predict the comrades on screen? Can you predict the stuff which comes up? What do you think will come up?
So
A bunch of mole calculations.
definitely moles.
There'll be at least one empirical formula question.
Yeah.
100%. We had stuff on alkanes and alkenes in paper 1. So it's probably stuff about esters and carboxylic acids are going to come up. There's probably going to be a brief section on equilibrium and 100% electrolysis. Like, they love the stuff. So that's my 4 predictions.
Okay. That's quite simple. Electrolysis.
There we go.
Electrolysis might come up as well.
That's
Oh.
Dyson. But
Yeah.
electrolysis is probably the most finicky subject, just because it's just annoying.
Oh, how much have we got left? Oh my days.
It's fine. We don't need
Should we speed run it?
We'll speedrun it.
Describe how the student could test a sample of copper sulfate to show that it contains copper
So it's just
2 ions.
it's a qualitative test. You add sodium hydroxide or ammonia.
Add
Sodium hydroxide or ammonia. So just do a bit. Don't do like excess, because excess is weird. But just add a bit of sodium hydroxide and it will form a light blue precipitate. There we go.
drops. And the positive test is
light blue precipitate.
Is a light.
Yeah, because in X is ammonia, it turns dark blue solution, but then it's
Light blue precipitate.
So for this, it's 3 marks, so it's probably going to be
Negative electron.
so the negative electrode.
First,
So
what?
the copper is reduced.
Copper. What? Copper is has a positive charge.
Oh yeah, so copper has positive charge and is attracted to the negative the negative electrode, which is called the cathode. Cathode attracts cations, so it's negative because cations are positive, and anode is positive because it attracts anions because it's negative.
Cu2 plus gains 2 electrons
Brackets
because
reduced.
it's 2 plus.
Brackets reduced because they might want it in the Marx cube.
3 Cu atoms formed.
Okay, let's just choose it. Yeah, copper ions are positively charged, attracted, accept electrons, become copper atoms. Yeah.
Okay, great.
Also, just write the half equation because they probably get a bunch of stuff for that. You don't write them, just go.
Okay, that's the half equation if you want.
Where are references?
State the appearance of the copper that forms on the negative electrode. So
It's a pink brown.
pink brown.
That's what I love.
What is it?
Oxygen forms on the positive electron. So in the presence of oxygen, a glowing splint will relight. You should know this though. I believe that the majority of people know that.
Yeah. Complete half equation. Oh dear.
Damn, that's actually difficult.
Formation of oxygen as a positive electron. So firstly, we're gonna make oxygen, aren't we?
Yeah.
Okay. And then we're gonna make H plus.
H plus and
So we need 4H plus and 4E minus.
yeah.
So basically,
We won't bring it up now because we're sort of short on time. But just you probably have a section somewhere. I'll just look it up. Where just look up for like half equations for oxygen forming and hydrogen forming for like each electrode, because they tend to ask those rather than actual elements. So the main one to know is just oxygen forming because it's slightly weird.
loses electrons. So oil rig.
Also,
Oxidation's loss reduction.
remember, if it's asking why is something getting oxidized, it can also be because it's gaining oxygen. So just make sure of that. So don't immediately assume it's to do with electrons.
Yeah. Okay. Suitable catalyst. So ester.
And ester.
Right. So what we just talked about ester.
We talked about ester at the start. So it's going to be conc H2SO4. Yeah. If you're adding like a catalyst or something, just when using an acid, just always default to sulfuric. Hydrochloric usually has issues.
Probably don't need to put conc.
Yeah, you just
explain how you know that an ester is formed.
As we went before, fruity smell or oily drops. Yeah. Where is it? Fruity. It goes for fruity smell here, and also accepts oily there.
Okay. Give the name of this ester. Right.
So we went over. So they've tried to trick you
here.
Here. They've tried to trick you here by putting the carboxylic acid thing on the left, but because there's like the O2, like the O double bond, we know the carboxylic acid is on the left and the alcohol is on the right. There's one.
So one's going to be methyl. There's a methyl, and that's ethanoate. Yeah. So it'll be methyl ethanoate.
Jesus Christ!
Right. Who's spamming, bro? Can you please stop
it's
spamming?
Literally John Landon, bro.
Have some Q. Have some Qs in a week, bro.
We're not even doing that. Literally 0 individuals.
Stay which okay. Yeah. Stay which 2 bonds needs to be broken in the reactants. Right. Let's go back. So if we look at the product, okay, what do we see? There's like this bit, and then there's that bit, and that bit comes from that, doesn't it? So we need to break the OH of that, and then that bit comes from that. So we need to break the CO of that.
Yeah.
Yeah. So OH and CO.
Oh, another thing they like to ask especially when dealing with esters, is they love to ask why the enthalpy. Oh, it's literally this next question. It's literally this next question. So I've got an answer I wrote here like earlier. I'm trying to find it. Sorry. Yeah. Okay. So the number of each type of bond which is broken is the same as the number of each type of bond made. So that, and then you say breaking bond requires the same amount of energy as is released when the same type of bond is made.
So bond breaking
is same energy.
Requires
same energy.
Same E as bond making releases. So the overall energy change is going to be 0.
Yeah, and also if you just want to be safe, as much energy is used to break bonds as is released by bonds made.
Right, so carbon monoxide. Why is carbon monoxide poisonous? Carbon monoxide hinders oxygen transport. Yeah. So just write something along the lines of that.
Yeah.
You can also write
or binds hemoglobin better than oxygen.
Explain the effects on the yield of hydrogen when a nickel catalyst is used. Right. So, did we go through this when we did equilibrium? Catalyst on equilibrium.
Yes, we did.
So catalyst does not change the position of the equilibrium. So no effect. No effect. Because you have to explain it, and it's 2 marks.
Because it speeds up the rate of both the forward and the backwards reaction equally.
Speeds up forward.
Yes, you can say it affects hemoglobin for the carbon monoxide. Backward reactions equally. Stop just cooking in the chat.
Oh, right. The reaction conditions for this reaction are temperature of that and that is reduced to 600, but pressure is kept at 5 atmospheres. So what we have here, we're reducing the temperature, right? So
there's no pressure change, so you don't need to worry about it.
So if we look back here, if we look at the delta H, it's positive. So that means it's endothermic. Okay. So if we go back, if you're decreasing the temperature, the equilibrium wants to increase it back to counteract the change. So we want to go to the exothermic direction. And because the forward reaction is endothermic, the backward reaction is exo.
Yep. Yeah, bro, you're right.
Yeah. Okay.
You don't need to keep on
decreases, and because forward is endothermic and backward is exothermic.
Should drop by it. Okay.
The pressure of the reaction is reduced, but the temperature is kept. So we're reducing the pressure.
It's literally what we went over in the
right. Let's go back. So 1 mole. That's 2 moles on the left hand side, and 1 3 is 4.
So obviously 4 is gonna.
So if we're reducing the pressure, we want to
increase the pressure.
More moles.
So it's just gonna be the forward reaction.
Increase. Because right hand side has more moles of gas.
I don't think so.
And RHS is right hand side.
Yeah.
In case you didn't know.
Do you really want to
calculate the volume to produce 6.6 tons? Right,
we'll just skip.
Oh, this is the last question.
The last question. We did it.
Right, 6.6 tons. So the mass of hydrogen 2 is 6.6 times 10 to the 6, because 1 ton is 10 to the 6 grams. And now, if we get the triangle back, M and MR.
Yeah.
Okay, and we want to find the moles of hydrogen. So moles of hydrogen is going to be mass divided by MR. So the moles is 6.6 times 10 to the 6 divided by 2, because H2 has 2 hydrogens. So that's going to be 3.3 times 10 to the 6 moles. Then we want to get the moles of methane gas.
Check the Wi-Fi doesn't conk out. And it might be right in a second.
Methane. So wait, what do we have? Methane. 1 methane goes to 3H2. So 1 methane, 3H2. That means that we need a third of the methane to make the same amount of hydrogen. So it's going to be 3.3 times 10 to the 6 divided by 3, which is 1.1 times 10 to the 6 moles. Okay. Now that we have the moles, we can use the molar volume. That just means the number of moles, the number of dm cubes of gas in a mole.
Yeah. And it's always the same for every single gas.
Yeah. So now we have the volume, which is 1.1 times 10 to the 6 times 24 dm cubed. 24. Which is 2.64 times 10 to the 7.
Yeah. That's the answer. So because the answer's in dm cubed, so obviously that was fine to keep it like that. But just remember, read what it wants it in, convert, and make sure it says, if it says significant figures, standard form, or whatever, just do it in that form.
So if they don't ask for sig figs, the safest thing to do is just to give everything to 3 significant figures, because they'll always accept that. Yeah. Unless they specify otherwise. Right, and that is the entire paper.
So, just does anyone want to do anything specific, like after that?
Does hyperconjugation only work on alkyl groups? Hyperconjugation is an effect on carbocations. I'm not sure where alkyl groups come in. Alkyl groups cause hyperconjugation, but I'm not sure what your question is.
Do metal uses, so metals and alloys, I guess. You know what metals and alloys? You just got
metals. Okay, metal uses and alloy uses. Let's do it. Right. Metals and alloys. Where's metals and alloys?
So for that, you just want to say, well, for like, why is an alloy stronger than a metal? You essentially want to say, so in an element. So in an element, it's in a regular lattice, so arranged in neat rows. These rows can easily slide over each other. In an alloy, first one will be so there's a difference in size between the atoms. It will be arranged more randomly. The layers cannot easily slide over each other.
I need to arrange randomly to my thing.
Where's the dipole H? What's dipole H?
Dipole, I don't know. Man does Olympians.
What dipole H doesn't mean anything, bro.
They're just
Right, okay, let's so uses of aluminium, copper, iron, and steel.
different shaped atoms. What are you on about? Different size.
Bro, we're just trolling.
We're just trying.
Aluminium. What is aluminium? Aluminium is like light, okay, and is malleable. So you can use it to make cans
And aircraft because it's light.
and planes.
I did a cooking pan.
Copper.
It's conductive.
Copper is
It's ductile. It's conductive.
Good.
So for wires.
conductor. And ductile. That just means you can make it into
Bro, what
like
is
a
this pole? Look at this pole, bro.
thin blood clot. Blah. So copper is wire.
Yeah. For the pole, I'd have to say zinc is more reactive.
Right. Okay.
He agrees.
Iron.
We
What is
both put in paper one.
iron? Is like iron is cheap. Actually, bamboozled. What's iron used for?
Iron.
Nails.
Iron is used for nails and like structures because it's just strong.
Iron. Yeah, you can say like strong.
But usually they'll waste the iron on like a rusting question.
Iron.
For iron, for
Iron
rusting,
over.
you can't just write iron oxide. Write hydrated iron 3 oxide because otherwise you don't get the mark.
Strong. Steel is strong, so it's used for like buildings.
Oh yeah, they did want to do condensation polymerization in the boxes
Okay.
because that is actually
Wait. Where's that guy else? Geography art law. Can you elaborate on your question? Please. Iron is used to make nails. Because it rusts.
because it rusts. It's used for all the rusting experiments.
Yeah. So that's basically it.
Metals,
Yeah.
They're also
Blah
pan.
blah 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 blah. Yeah. So steel contains carbon. All steel contains carbon,
So go
and stainless steel contains chromium.
Brack's dead. That's why we're doing
Okay.
this stream.
Don't need to know nickel. You just say stainless steel has chromium and carbon, and all steel has carbon, and stainless steel doesn't rust. So
I need to see. I want to get mine.
don't.
Chromium. Yeah, whatever. You probably don't need.
Okay. So steel
Condensation polymerization because that's what people want. Aluminium is more active. No, it's zinc, bro. I'm pretty sure of it. I was so certain of it. I put it in paper 1. So no.
What example is this?
Bro,
So
it's all of them simultaneously.
we just did a past paper for LXL GCSE,
Yeah. But
but
it's all of
literally
them.
the same, like same
Literally.
content, bro.
You don't need the syllabus.
Okay.
Just do it.
Condensation polymerization.
Just do boxes. So for condensation polymerization, we'll do both. We'll do both the ester one and the amide.
Polymerization.
For Edexcel, you don't need to know amide, so yeah, it's fine.
So condensation polymerization. What is it? So what does condensation mean? It means it releases small molecule.
Usually this is water or hydrochloric acid.
Yeah. Water.
No,
Say
it's zinc. You're very much wrong.
Right. Can I have some juice?
It's because you're juice.
Bro,
Yeah, right.
you're having juice right now. What do you want? Release a small molecule. So, what do you need for condensation polymerization?
You
So
need
basically,
You need either a dye, like a diol,
diol and
a
dicarboxylic
acid.
So diol, that just means 2 times OH.
Yeah.
And dicarboxylic acid just means 2 times COH.
yeah.
Okay. So diol, if I just draw like a box. Yeah. OH. Carboxylic acid. COOH. I'll do a hexagon. This one.
What?
Because it has to be different.
Just do a circle.
No. Right. So what it's going to do is, we already went through esterification with an alcohol and a carboxylic acid. And what does that esterification is the functional groups. So the OH group on that is going to react with the COOH.
Just circle like the hydrogen and the oxygen.
Yeah. And what's going to happen is the OH is going to go away and the H is going to go away.
And that's going to form water.
And it's going to make one bond like that. And the H and the OH are going to make water. So the
repeating unit
product
will be like long.
Hold on.
Wait, what's it called?
Right, and same. It's the same thing. And COH there, the COH there is going to react with another OH there with a rectangle. So it's going to just like infinitely repeat. So the repeating unit is going to look like
So make sure with the repeating unit you include like the carboxylic bit and the O bit on the left and the right. You don't just like draw the box and then draw like the box and the hexagon and then just draw a line.
Right. 2.
Amides.
Amines and just like amino acids, I guess. Amino acids. So this makes polypeptide.
And this is the last thing we're gonna do.
Wait, and we're also gonna do hydroxy.
We've got
acid.
4 minutes.
It's fine, bro. I'll make it quick. And polypeptides / polyamides. Amino acids basically has an amine, which means it has N with 2 H's, and acid is just COH. And what the COH is going to do is it's going to react with the amine of the other one, and again we'll make 1 water, and the repeating unit here is going to look like CO there. And the repeating unit only has 1 rectangle because the monomer is there's only 1 type of monomer, which is the rectangle. Okay. 3. Hydroxy acids.
When have we ever done that? Like usually for these ones, they'll just give it to you.
Yeah, is hydroxy acid is just HO and then box and then acid. It's like that. And the
It's the same thing. It forms
yeah,
water. It forms water. And
same
does
thing.
The whole
blah
shit.
blah blah. And basically, the repeating unit is the same as this one. You don't really need to know this. You just need to be aware.
A lot of the time, it will give you basically everything you need to just figure it out.
Yeah. So the repeating unit is just going to be O there, and that's it.
That's it. Okay.
Right.
I think that's it.
Yeah.
Good luck, everyone, tomorrow. Or
Yeah. Good luck.
Good luck for chemistry. You'll get a 9, I'm sure. It'll be fine. Yeah. Don't panic. Write a lot. You got time, and just read the goddamn question.
Oh.
Yeah. Cool.
Any last questions? We've got 2 minutes. The stream's going to end in 2 minutes.
Your question will be forever lost. I don't know why my chat's not working. We haven't been having chat for like 10 minutes. There you go. Minute time's out.
Any last questions? You're very welcome, Devon. You're very welcome.
Okay, I won't panic, bro. Don't worry. Okay.
How big is it?
How big is what?
Bro, stop getting freaky. This is a family-friendly channel.
What? You're the one who really asked.
No, he said how good, how... Okay. Right.
W stream, guys. W stream.
Yeah.
Subscribe.
Right.
Subscribe.
Everyone, apa ko kamayabe mille, okay?
Subscribe.
Latte Fats, thank you very much for watching. I
Subscribe,
hope you get 9.
Pay us money. I don't know.
Mateo needs it. He needs it.
Who is your favorite mod? Clearly it's aldehyde.
It's clearly aldehyde.
Clearly
Keko.
aldehyde.
No,
Keko.
Keko sucks.
Not
Keko.
Keko sucks. Anyway, bye.
Alright, bye Spanish.
Bye. Good
Love
luck,
you guys.
Good luck, lads.
Goodbye. Goodbye.
Don't-
How